Hi, welcome back to the channel. This is structural analysis made fun and easy. This is analysis of statically determinate frameworks 1, internal forces, chapter 2. I'm looking at these 3-pinned arches, 2.7.3, 3-pinned arches. An important group of articulated structures are the 3-pinned arches. These are plane frameworks which consist of arches supported on pin supports at the feet and containing a single internal hinge, usually at the crown. A portal frame example is shown in figure 2.47. Comparing this with the pin-fitted portal frame discussed in examples 2.8 and 2.18, an extra reaction is necessary to restrain the horizontal movement of the right-hand foot. The extra equilibrium equation is obtained by taking moments for a subsection of the structure to one side or other of the hinge of the crown. So here's the example. There's full and the horizontal full widths of 3 meters. So you've got 3, 6, and then you've got the hinge, then 9, then 12. You've got one lateral load of 2 kilonewtons per meter, then these point loads 5, 10, 10, 8, 4. The height of the pitch is 2.5 and the height of the columns is 4. So this is the free body diagram of it. R1, R2, R3, R4, then the forces. Example 2.22, 3-pinned arch portal frame. Consider the 3-pinned portal frame shown in figure 2.47a, having the same geometry and loading as the portal frame in examples 2.8 and 2.18. The free body diagram is shown in 2.47b. Whence the global equilibrium equations and the hinge equation from the subsection of the framework to the right hinge take the form. So you've got R1 plus R3, or horizontally, R1 plus R3 plus 2 times 4 equals 0. R2 plus R2, R2 plus R4, then vertically, R2 plus R4 minus 37 equals 0. Take moments in the z-axis about 0.1. So that's all those loads. The lateral load minus 2 times 4 times 2 times 10 times 3 minus 10 times 6 minus 8 times 9 minus 4 times 12 plus R3 times 12. I'm not sure if it's supposed to be R3 or R4. The moment's about... And then, then he says... And then the hinge equation is the fourth one here. So you take moments about... about joint 3 to the right hand side. So that's 3 times 8 minus 4 times 6 plus R3 times 6.5 plus R4 times 6 equals 0. And then you solve those equations here. I'm not sure if that should be R3 in the third equation or R4. I'm going to check that in the next video. R1 equals 2, R2 equals 18.7, R3 equals minus 10, and R4 is 18.83. The stress resultant diagrams are then plotted in the same way as for the example 2.18 and figure 2.48 is the bending moment diagram produced by the spot value and interpolation method. It's interesting that the change in support conditions and the internal hinge completely change the bending moments within the framework compared to those within the pin jointed framework in 2.38. So we're going to go back to that one. In particular, we now have large hogging bending moments at the eaves that are characteristic of frames dominated by vertical loads. That's the bending moment diagram. So this is just a 5-minute video about this pinned arch. And I'm going to go back to example 2.18 and compare it also to figure 2.38. Hopefully you found this video useful. This was just a quick video about pinned jointed pinned arch, three-pin portal frame, three-pin portal frame. Hopefully you found this video useful, and then I'll go through and do another video in more detail. Please like and subscribe to the channel. Thanks for watching.